Hey guys, welcome back to the laboratory. In this video, we are looking at the different reactions with acids. By the end of this video, you should be able to define the term base, write word equations for the reaction of an acid with a base or a metal, and explain how ions are rearranged during neutralization reactions. So, let's go. Before we delve into the main concepts of this video, it's important that we first visit the role and importance of chemical equations in chemistry. In chemistry, chemical reactions are represented using chemical equations. These chemical equations can be expressed in either word or symbol form. In either form, a chemical equation will always follow the same simple format. The reactants are written at the beginning of the chemical equation. These are the substances that will undergo the chemical change during the reaction. And the products are written at the end of the chemical reaction. These are the substances that are formed as a result of the reaction. In a word equation, the chemical reaction is expressed using the names of the substances that are involved in the chemical reaction. For example, when sodium oxide reacts with hydrochloric acid, the products of the reaction are sodium chloride and water. The word equation for this chemical reaction would look like this, where the reactants, sodium oxide and hydrochloric acid, are written at the beginning of the reaction, and the products, sodium chloride and water, are written at the end. In contrast, symbol equations express a chemical reaction using the chemical symbols of the substances involved in the reaction. The symbol equation for the reaction between sodium oxide and hydrochloric acid would look like this. Take note of these small letters that follow the formula for each substance in this question. These are called state symbols, and they are used in symbol equations to tell us the state a substance is in during a chemical reaction. The state symbol S tells us the substance is a solid. L tells us the substance is a liquid. G tells us the substance is a gas, and AQ tells us that the substance is dissolved in water. Now we can use this information to discuss the different reactions with acids. We'll start firstly with neutralization reactions. A neutralization reaction is a chemical reaction that takes place between an acid and a base. A base is any substance that can neutralize an acid, such as metal oxides, metal hydroxides, and metal carbonates. Now, let's pause here and clear up a common misconception. As mentioned, bases are a family of chemicals that can neutralize acids. Alkalis are a type of soluble base, but not all bases are alkalis. This is similar to the ideology that lions are a type of big cat, but not all big cats are lions. Try to remember this when discussing alkalis and bases, as it can become quite confusing otherwise. When a neutralization reaction takes place between an acid and a metal oxide, the products of the reaction are always a salt and water. The general equation for this reaction can be written like this, where the acid and the metal oxide are the reactants, and the salt and the water are the products. The name of the salt produced during the reaction is determined by the base and the acid that are reacting. If hydrochloric acid is used in the reaction, then the salt produced will be a chloride. If sulfuric acid is used in the reaction, then the salt produced will be a sulfate. And if nitric acid is used in the reaction, then the salt produced will be a nitrate. For example, the neutralization reaction between hydrochloric acid and magnesium oxide forms magnesium chloride and water. The first name of the salt is always the same as the metal found in the base, which in this case is magnesium. The second name of the salt is determined by the acid. As the acid used is hydrochloric acid, the salt is a chloride. Had the acid used been nitric acid, the salt formed would be magnesium nitrate. However, had the acid used been sulfuric acid, the salt formed would have been magnesium sulfate. The neutralization reaction between an acid and a metal hydroxide will also produce a salt and water. The general equation for this reaction can be written like this, where the acid and the metal hydroxide are the reactants, and the salt and the water are the products. For example, the neutralization reaction between hydrochloric acid and copper hydroxide forms copper chloride and water. Once again, the name of the salt has been determined by the acid and the base that have reacted. The first name of the salt is taken from the metal in the base, and the second name is determined by the acid that has reacted. The neutralisation reaction between an acid and a metal carbonate yields slightly different products. This time, the products of the reaction are a salt, water, and carbon dioxide. The general equation for this reaction can be written like this, where the acid and the metal carbonate are the reactants, and the salt, water, and carbon dioxide are the products. For example, the neutralisation reaction between hydrochloric acid and magnesium carbonate forms magnesium chloride, water, and carbon dioxide. Once again, we can see that the name of the salt is determined by both the acid and the base that are reacting. During a neutralisation reaction, the oxide or hydroxide ions from the base combine with the hydrogen ions from the acid to form water. The removal of the hydrogen ions from the solution neutralises the acid and thus brings the pH of the solution closer to neutral. For example, in the neutralisation reaction between hydrochloric acid and magnesium oxide dissociates into magnesium and oxide ions. The oxide ions combine with the hydrogen ions from the acid to form water molecules, and the ions left in solution combine to form the salt, magnesium chloride. The final reaction we will explore during this video is the reaction between an acid and a metal. This time, the products of this reaction are a salt and hydrogen gas. The general equation for this reaction can be written like this, where the acid and the metal are the reactants, and the salt and the hydrogen are the products. For example, the reaction between hydrochloric acid and magnesium form magnesium chloride and hydrogen. Once again, we see that the name of the salt is determined by the metal in the acid used during the reaction. Here's an example of a past paper question that you can attempt to test your understanding of the concepts covered in this video. Pause the video and take your time to work it through. Press play once you're ready to check your answers. Part 1 of this question asks for you to name the salt formed in the reaction between aluminium oxide and hydrochloric acid. As we have discussed, a salt will always consist of two names, where the first part is determined by the metal in the base, and the second is determined by the acid that is reacting. Using this logic, we know that the name of the salt formed is aluminium chloride. The second part of this question asks you to name the type of reaction that has taken place between hydrochloric acid, which is of course an acid, and aluminium oxide, which we are told is a base. The only correct answer to this question is of course neutralisation. So, how did you do on this task? Let me know in the comment section below. Anyway, that's it for this video guys. Thank you for joining me in the laboratory. Please leave a like on this video if you found it useful, and don't forget to subscribe to the channel so that you don't miss another one. See you soon!